This is going to be the 7th grade probability practice along with the benchmark practice. I know you guys have not had a ton of probability yet, but I want to try to get you guys prepped for what's going to be on the benchmark. Starting with number 1, it says, which diagram best represents all possible outcomes of rolling a number cube numbered 1 through 6 one time? So it's just talking about a die. So if we're talking about rolling it one time and we have 6 options, we've got to figure out which one of these has a single roll with a total of 6 options. Well, that's only 4 options, so that one is out. Again, single roll, a total of 6 options, that one is out. Single roll, 6 options, out. Single roll, 6 options, that's the one that we're looking for. Okay, that's just how tree diagrams work. I know we haven't talked a whole lot about it yet, but just something I need you guys to be able to recognize for now. Number 2, Sydney wants to participate in an after-school program. She has the choice of 2 art classes, 3 dance classes, 2 gymnastics classes, or 3 sports classes. She cannot decide, so she writes the name of each class on a slip of paper and draws one slip out of a bag. What is the probability that she does not draw a dance class? So first thing that we got to do is we got to figure out the total number of slips of paper that she's going to have in the class. So if you guys will remember, when we talked about probability, we talked about the probability of something being what we want over our number of possible. So first we got to figure out what it is that we want. Well, we're trying to figure out what is not a dance class. So actually, I know I said that I want to figure out what we want, but let's figure out the total number possible first, because I think that's going to be easier. So first we've got the 2 art classes, 3 dance classes, 2 gymnastics, and 3 sports classes. When I add all those up, I get a total of 10 classes that she can choose from. Well, out of those 10 classes, we're trying to figure out which one is not dance. So 3 of those 10 are dance classes. So what we want is not dance. So we're going to do 10 minus 3. So we have 7 classes that are not dance. So I'm going to put my 7 above there, and I'm just going to look for that answer on my answer choices. On to number 3. Julia spun a spinner 35 times. The table below shows the number of times the arrow of the spinner landed on each of the 6 colored sections. Julia wants to predict how many times the spinner will land on yellow if she spins the spinner 50 times. Which of the following correctly explains Julia's prediction? Before I bother with that, again, I'm going to remind you that our probability is always going to be what we want over our number possible. So I think it's going to be easier if we go ahead and know what our total number possible is. I'm going to add all of these up first. All of those together equal a total of 35. So that's going to kind of help me figure things out. What we know is that this is going to be some kind of proportion. Whatever our want is going to end up going up here, and we can use that to set up some kind of proportion for over 50, because 50 is the total number of times that she would spin that spinner. Once we know what goes here, it will help us solve for whatever this is going to be over here, okay? So A says, Julie predicts the spinner would land on yellow 22 times. Since it landed on yellow about 3 less than half the time, it will also land on 50 about 3 less than half the time. Gonna be real honest, I didn't understand any of that second sentence. It would take me a little while to try to figure out what they're talking about, so here's what I'm gonna do. I wanna know if it's gonna land on yellow 22 times, so I'm gonna switch colors here. If it landed on yellow 14 times, I'm going to plug in 14 right here. And I can cross multiply, divide by the lonely guy. And when I do that, if I cross multiply and divide by 35, I end up getting 20. Well, they said 22, and that equals 20, so A is out. Okay, so now I'm going to change it up again. Let me reset what I've got there for my proportion. So now for B, says Julia predicts the spinner would land on yellow 20 times. Okay, well that's what we figured out. That, in fact, I'm not going to even bother with that one. That one sounds pretty darn good so far, because we just found out that it would land on yellow 20 times. On C, says Julia predicts the spinner would land on yellow 35 times. Well, that's not true. We just proved it. D, Julia predicted the spinner would land on yellow 33 times. No, we already figured out that if we plug in that 14, I guess I could have kept what I had written there. If we landed on yellow 14 times out of those 35 spins, I can cross multiply, divide by the lonely guy, and X comes out to 20. So B is definitely what we are looking for on that one. Backside. Number 4. Paige is conducting an experiment using 2 spinners. She spins each spinner, records the result, and then spins again. She repeats this experiment 10 times for each spinner. Her results are shown below. Based on these results, predict the number of times Paige will spin a blue spinner one, and and I think this is actually phrased differently on yours because I didn't like this phrasing. Pretty much, she's going to spin both spinners at the same time, and when you want to find out how many times she's going to land on a blue and an orange at the same time if she does this experiment 300 times. So they already told us, and again, I know you're getting sick of this part, but I'm going to go ahead and tell you again. Our probability is going to be what we want over the number possible. Well, we already know that she did this experiment. Well, if we got 4, 5, 6, 7, 8, 9, 10. She got a total number of 10 possible here, and she's got 10 possible here. That's what happened with her actual experiment. We have no idea what the spinner actually looks like. Well, on spinner 1, she's trying to get a blue, and before she landed on blue 2 times. On the other spinner, she's trying to get orange, and so she landed on that one 3 times. Because we're trying to see how often these two things are going to happen at the same time, we have to multiply these probabilities. So I'm going to take my blue spinner, the probability was 2/10, and I'm going to multiply that times my odds of landing on a orange spinner. So 3/10. I multiply these straight across. 2 times 3 is 6. 10 times 10 is 100. So this probability that I just came up with, a 6 out of 100, tells me that's the probability of landing on a blue and an orange at the same time. But here's what we want. We want it to know if she does it 300. She does this experiment 300 times. So the probability is 6 out of 100. So I'm going to set up a proportion for if I did this 300 times. Well, I can just scale up on this, which will make my life a lot easier. To get from 100 to 3, I have to multiply by 3. So if I do 6 times 3, that would give me 18 times. So if she does this experiment, I would expect her to land on blue and orange at the same time 18 times. All right, number 5. A recipe says to use 3 cups of sugar to make 48 cookies. What is the constant of proportionality that relates the number of sugar cookies made to the number of cups of sugar used? Pretty much it just wants to know how many cookies we are going to get per cup of sugar. So you can kind of set this up as a proportion if you want to, but I'm just going to say this is going to be cookies, if I can spell cookies right, per cup of sugar. So I'm just going to call it cookies per cup. Well, we had 48 sugar cookies. We had 3 cups. You can set this up as a proportion as x over 1 if you want to, but really it's just 48 divided by 3. For those of you that like WKUs, this is essentially a unit rate, so we're solving for x over 1, but what I'm going to focus on is just this 48 divided by 3. So if I do 48 divided by 3, I know that I'm going to get 16 right here. So our constant rate is going to be 16. Number 6, consider the shapes below. Generate ratios of side lengths within trapezoids STUV and within trapezoid KLMN to determine if trapezoid STUV and trapezoid KLMN are similar. Pretty much we're going to get a proportion for one and we're going to get a proportion for the other, and we're going to see if they're both true. Things that I want to do real quick, I do want to highlight similar sides just so I can make sure I'm setting up the same ratio. So for STUV, I'm going to highlight ST on that one in red, and I'm going to do, there we go, this will be better, and KL on that one on red. So ST is my long side here, and on the other one, KL is my long side here. I can change colors. So now I'm going to do TU, my 2 center letters, and LM. So TU is going to be blue, and LM is also going to be blue. My last 2 letters, UV and MN. So UV is my short, or not my short side, but my shorter of the 2 longer ones. And MN is green, and I'm just going to leave that last one black. So what I can do is I can use a ratio of any kind. So here's what I'm going to do. I'm going to make my ratio, I think I'm just going to do red to blue. So my ratio is going to be red over blue. And I can do that on each of these, and I want to know if I get the same number for both of these ratios. If I do, I'm in the clear and I'm done with this one. So for red, on the left side, I've got 2.25 over, I'm going to do that part in black, there we go, over 1. On the right side, I've got, what do we have here? 3.6 over 1.6. So really what I'm going to do is I'm just going to divide both of these and see if I get the same number. So I've got a calculator, so I'm going to cheat a little bit. I know you guys have to do this by hand, but tough. So if I do 3.6 divided by 1.6, I'm going to get 2.25. Over here on this side, 2.25 divided by 1 is going to be, unsurprisingly, just 2.25. So that's my ratio there. That's my ratio over there. We have a common ratio. We know that these are both going to be similar trapezoids. Number 7. Cole reads 50 pages of a new mystery book the first day she bought it. After the first day, he reads 22 pages a day. If the book was 450 pages, which of the following equations can be used to determine how many days it took Cole to finish the book? So in this one, I always like to start with our total. Well, the book is a total of 450 pages. So what I'm going to do is I'm going to look at my equations and see which ones have a total of 450. So that says equals 450, equals 450, equals 450, and equals 450. Unfortunately, that didn't narrow anything down for us at all, so now I'm going to have to start using my brain a little bit. So it says you read 50 pages on the first day. This only happens one time, so that plus 50 is going to be completely on its own. That 22 pages a day, well, he's going to do 22 pages every day, so we're going to expect to find something with 22x, or 22d for day, or however they're going to do it. So I see a 22x there, a 22x there, a 22x there. Well, at least I can get rid of that one there. Now, we know we have to have the 50 in there somewhere, so B really doesn't make any sense, so I'm going to mark out B for now. So now we got it down between A and C. Well, if he's trying to get a total number of books read, we know we're going to have to do addition. So A is what we are looking for on question number 7. All right, number 8. This one is just going to be a proportion. Set up a proportion, solve for X. My recommendation is whenever they are set up like this with the figures facing the same way, my proportion can look just like it's set up right there. I can do this 3 over 5 equals x over 12.5. Here's why this works though. That 3 is related to that x. That 5 is related to that 12.5, okay? So just to highlight my numbers that I've got here, I've got my 3 there, x there, and my 5 there, 12.5 there. On the left side, that 3 over 5 is figure 1. The right side is figure 2. So this proportion completely works out. So from here, I just solve it out. I'm going to cross multiply, divide by the lonely guy. So I would do 3 times 12.5. Again, I'm going to cheat with the calculator. So I get 37.5. And now I have to divide by that lonely guy. When I divide these two out, I get 7.5. So x is 7.5. Backside. Number 9. An equation with one variable is shown below. Which number line represents the solution for this equation? Okay, so we've got number lines. We could try plugging in answers, but guys, this is something that really you just need to be able to solve at this point, okay? If you're not sure, make sure that you're watching this because you guys need to be able to do this. Draw your line down the equal sign, and your goal is to get everything away from the variable. In this case, it's an x, so we want our x's cold and alone. So what I'm going to do is I got to get everything away from the variable. So I'm going to get rid of that 20. So I'm going to do minus 20 on both sides. These two will cancel out. On the left side, I'm going to be left with 8x equals 4 minus 20 is going to be negative 16. Final step, whenever I have a variable and a number right next to each other, I have to divide. So I'm going to do both sides divided by 8 because I want to get that variable by itself. Those two cancel out, and I'm left with x equals negative 16 divided by 8 is going to be negative 2. So negative 2 is my answer, but now I got to figure out which one of these shows me negative 2. Well, the only one with a dot on negative 2 is going to be B, because it looks like it's a little to the side, but it's supposed to be right there. Number 10. Lee conducted an experiment in the lab and recorded the data below. What is the constant of proportionality that relates the distance traveled y to the time in seconds x represented by this data? So right here it says distance is y, so I'm going to put that y there, and they say the time, seconds, is x. So whenever you have a table and they want a constant of proportionality, guys, I need you to remember that slope, constant of proportionality, unit rate, change of y over change of x, rise over run, all of that stuff is the same dang thing. So easiest way to do these is going to be the change of y over the change of x. And you can use any set of numbers on there. There's actually an even easier way to do this one, but this was kind of our fail-safe that always works. So what I'm going to do is I'm going to look at, didn't really matter what pair I pick. From 3 to 6, our y changed by 3. From 1 to 2, our x changed by 1. So it's really just 3, whoops, that's a terrible looking 3. 3 over 1, and 3 divided by 1 is, unsurprisingly, just 3. So our constant of proportionality, our m, our rise over run, all of that stuff is just 3. On number 11, it says consider the graph and write an equation that represents the relationship between x values and y values in the graph. Anytime it's looking for something like that, your solution is going to look like y equals mx plus b. I always recommend starting with b because it's the easiest one to figure out. This is easy. That's wherever it crosses on the y-axis. I don't know why they use a b for y-intercept, but they do, so deal with it. So my equation has to end with a plus 1. The rest of the equation is pretty much straightforward. It's still going to be y equals something with an x. Now we have to find our slope, or our rise over run. So for rise over run here, I can see that I've got a second point right here. I'm going to rise that much, and I'm going to run that much. So my rise is 1, my run is going to be 3. And this is positive because this graph is going up from left to right. So this is a positive 1/3. So now I'm going to take my slope and I'm going to plug in 1/3. This is the equation we are looking for. Slope of 1/3, y-intercept of 1. Number 12. An evil villain used a shrinking ray, which caused a superhero to decrease in size by 130 centimeters over the course of 5 seconds. How much did the superhero change in height each second? I'm sure that in this situation, the superhero is super concerned by how much he's shrinking every second. I mean, maybe he would be. All right, so it wants, this is kind of a constant of proportionality. It's changing each second. So this is, if you like unit rates, you can do this as a WKU or whatever you want. Really, I'm going to go ahead and tell you, it's really just 130 divided by 5, done. But for those that don't want to do it that way and you like WKUs, I kind of like them. Sometimes they're a little unnecessary. I feel like this is one where it's not super necessary, but we're going to do it anyways. Our words, we are talking about centimeters and seconds. That's supposed to be an M up there. Just pretend like it looks like like cm. And we know that it's 130 centimeters. And we know that's in 5 seconds. And what we want to know is we want to know how much he's changing each second for 1 second. So I'm going to have my x up here. So I could cross multiply, but again, it really just comes down to 130 divided by 5. So whenever you divide those, you get 26. So he is shrinking 26 centimeters every second. All right, number 13. Nicholas has 5½ cups of flour. The recipe for a cake he is making calls for 3 3/4 cups of flour. And he also needs 8 cups of flour for a cookie recipe. How much more flour will Nicholas need to make cake and cookies? I kid you not, I absolutely hate this problem, but this is real world. This is basic fraction stuff that you guys really need to be able to do. All right, so just to go ahead and get going on this thing, here's what he's got. Here's what he needs. I'm going to find out how much he needs, and I'm going to subtract how much he's got so I can figure out how much more he needs. And that, I mean, that's pretty basic logic right there, but what's going to throw you guys is that you've got to use your math skills and put these together. Well, 8 plus 3, so 8, 9, 10, 11. So we're going to have 11 3/4 cups. That's how much he needs. All I've done is combine the cups of flour that he needs for one recipe and the other. But now what I've got to do is I've got to subtract off this 5½. 5½ is what he's got. Whenever I subtract these two, this is going to tell me how much more he needs. Now, there are far simpler ways to do this part. I'm going to show you guys sorry, that's supposed to be a 3 there. I'm going to erase this and start over with that 3 because that is just terrible. There we go, 3/4. There are easier ways to do this, but I'm going to show you guys what I think a lot of you are used to. Just because I don't want to try to teach you something brand new at the last second. And it's not really brand new, but some of you guys haven't, I'll be honest, you haven't developed the reasoning skills for it yet, so I'm just going to show you what's normal. Some of you guys are used to popcorn or the Texas method or whatever else you want to call it. So we do 11 times 4, which is 44, plus 3 more is going to be 47. So I have 47 over 4. And I've got to do that minus, here's my other Texas method on the other one. 5 times 2 is 10, plus 1 more would be 11, so I have 11 over 2. Now, in order to be able to subtract these, I have to have a common denominator. So the easiest common denominator to get to is going to be 4. So in order to get this thing right here to 4, I've got to do both of these times 2. So when I do that, this is going to change to 22 over 4. So I'm done with that part. Now I can just do the subtraction. Do 47 minus 22. I'm just subtracting straight across. And I get 25 over 4. That is not an incorrect answer. 25 over 4 is perfectly acceptable, but you guys are going to have mixed numbers as your answer choices, so you need to be able to write this as a mixed number. So 4 can go into 25, let's see, 6 times, because 6 times 4 is 24, and that will leave me 1 part left over out of 4, so 6 1/4. I know that's kind of hard to do without the visual on it, so if you got questions on that, please ask and I'll come by and help you out. All right, last couple, we're almost there. Number 14. The tree diagram represents a relationship between sets and subsets of rational numbers. What kind of numbers should be placed in section B? All right, so rational numbers. I want you to remember that these are like decimal numbers. We've got parts, we've got fractions, no weird numbers like pi, and we also have positives, negatives, whatever else. Down here, it looks like we've got whole numbers because we're including 0. So these are whole. So what I need you to know is the only difference between whole numbers and the next section are the negatives. We have positive and negative. That's supposed to be a negative. What am I doing there? Positive and negative whole numbers up there. That's supposed to be an arrow, sorry. So that section is just going to be called integers. So in there we can put integers, or any numbers that look like integers, like -1, -2, -3, -4, -5, or any of those other ones. Final one. Number 15. An architect built a scale model of a building using a scale where 2 inches represents 25 feet. The height of the building is 200 feet. What is the height of the scale model? Okay, this is a flat out WKU. Guys, I hope you are getting pretty good at these because I'll be honest, I'm getting pretty sick of these. We know that we're doing inches and feet. Don't bother converting. That's the whole point of this ratio for us. We're going to do inches to feet. I could do feet over inches, but I like doing it in the order that it says it in. And that whole part right here, this tells us everything that we need for this, setting up these first 2 fractions. It's 2 inches, and it's going to be 25 feet. What we're trying to find out is we're trying to figure out if this building is actually going to be 200 feet, what is it going to look like on this model? Well, feet is going to go on the bottom, because that's where we already set it up. And from there, it's cross-multiply, divide by the lonely guy. I also try to scale up. You can do 200 times 2, and then divide by 25, or I know that 25 goes into 104 times, so it's going to go into 200 8 times. So here, I'm going to also just do times 8. So that model should be 16 inches tall.